I'm convinced that the age of the earth is an absolutely critical issue in the creation-evolution controversy. Of course, many scientists, not all, but many tell us that the earth is billions of years old. We're told that it's something like 4.6 or 4.75, depending on which authority you talk to, billions and billions of years old. And this is absolutely essential, absolutely critical for the evolutionary position. To show you the role that this plays in the evolutionary thinking, notice the statement by Lawrence Badash, who's professor of history of science at the University of California at Santa Barbara. He says, referring to the 4.5 billion-year-old earth, where it began out of a spinning turbulent cloud of gas, he says, on these figures for the age of the earth rest all of geology and evolution. This is the foundation of the thinking of evolutionary geology. It is absolutely necessary because it's impossible, obviously, to have evolutionary processes happening in a short period of time. George Wall tells us how this works in the thinking of the evolutionist. He's a Nobel laureate from Harvard. He says, however improbable we regard this event, he's talking about the origin of life. And in this discussion, he points out that this is just impossible. Those are that's his term. It is so complex and so interdependently complex that you see that this is not going to happen by itself. But he says, however improbable we regard this event or any of the steps which it involves, given enough time, will almost certainly happen at least once. He says time is in fact the hero of the plot. Now this is the solution, you see, to all of the impossible problems. And no matter how improbable you show it to be, it doesn't matter, you see, you have time. He continues, given so much time, the impossible becomes probable, the probable virtually certain. One has only to wait, and time itself performs the miracles. And so this is somewhat the Holy Spirit of the evolutionist that solves the impossible problems and performs miracles. You have a problem that says you just can't get this done, that's no problem. You just wave the magic wand of time. We've all heard the story of the prince kissing the frog, and magically the prince turns, or the frog turns into the prince. And that's, of course, a fairy tale. We know that's not realistic, except it is taught as realistic. This is exactly what we're taught in the schools today if you add one simple element. The magic wand of time makes it scientific. And now then, the frog does turn into the prince, given billions of years. Well, I don't think time has that power. Time actually is a disordering factor. And as we learned when we talked about the second law of thermodynamics, the more time involved, the more disorder is introduced into the system. This is not an organizing principle that causes things to go uphill. It's just the opposite. But this is what they rely on as their miracle worker, their Holy Spirit, if you please, the magic wand to solve all the impossible problems. When we talk about the age of the earth, I like to ask why questions. People just hear over and over again that the earth is billions of years old, and sometimes it's difficult to get people to stop and think. So I just say, why do you think the earth's billions of years old? And usually the first response that we get involves radiometric dating processes. After all, they've dated the rocks. They know from dating the rocks that they're billions of years old, and most people have no idea how such processes work. And so they just say, well, that must be, the scientists have dated it. They have somewhat maybe the impression that some of the teenagers got when they heard that we were going to talk about radiometric dating. And the idea reflected here is not quite the idea. But people not knowing how to be critical on this issue just accept it at face value. And we're not going to give a school on exactly how it works, but I think you can get at least a general concept. Radioactive material is material that emits particles from the nucleus of the atom and thus decays down to become other elements. These emitted particles are sometimes detected by Geiger counters, and you can detect then the radioactivity decaying into different elements. And it's supposed to tell time something like this hourglass. You begin with the radioactive material at the top, and it decays down to more stable materials at the bottom. For example, with uranium-lead, we see we begin with 238 particles. It decays down to lead at the bottom, which is stable at 206. Of course, we do know lead occurs naturally. Some occurs radiogenically, and you have to guess which is which. But this is the process by which we're supposed to tell time. We can use this equation at the bottom to determine that. Now, how would you run into problems with this? What would be the potential problems with this kind of a time-telling mechanism? Thinking of it as an hourglass, you look at this and you know it takes an hour to run from the top to the bottom. How much time has transpired with this hourglass? Well, you look at it and you calculate and you say, well, maybe 15 minutes, 20 minutes. And if you could precisely count the grains of sand, then you could precisely tell how much time has transpired. And counting grains of sand is certainly not the problem in this analogy with radiometric dating. We can virtually count the atoms in the process. But what could go wrong? Well, suppose just before you made your calculation of 17 minutes, someone had lifted the lid and poured a lot of extra uranium in the top to completely skew the calculation. Or suppose someone had lowered the bottom portion and had let a lot of the lead out. It had been almost full down there, and they let it out, and now then it's just a little bit left, and it should have been more like most of an hour, and now then it looks like 15, 20 minutes. Suppose it ran fast sometimes and slow the other. The orifice got larger. Or suppose just before you looked, it had been laying on its side with proportions just like we see it, and then they turned it up 2 seconds later, you looked at it. And only 2 seconds had transpired, and you concluded 17 minutes. Well, these are the kinds of problems that are involved in the radiometric dating systems because they're not closed systems. This material leaks in and out of the rocks over billions of years, and we do know there are some factors that cause the rate to change. Some don't know that, but experimental evidence has demonstrated that. Notice the statement by Henry Fall in his book, Ages of Rocks, Planets, and Stars. He says, 2 important assumptions are implicit in this equation. And that's the one at the bottom of the chart that allows you to reach the conclusion about years. First, that we're dealing with a closed system. Nothing leaked in, nothing leaked out, in other words. And second, that no atoms of the daughter, that's what's down at the bottom, produced, were present in the system when it formed. Now, of course, we know they were present. It's a matter of guessing how much. These assumptions furnish the most serious limitations to the accumulation clock. Now, this is not a creationist saying these are assumptions. He believes in it. He's an authority in the field. But he acknowledges these are serious limitations, assumptions, that are necessary to reach the age. You don't really date the rocks. You measure the sample activity and through a set of assumptions reach a conclusion about the age. He continues saying rigorously closed systems probably do not exist in nature. And not only do they not exist, we would add, he's talking about it not existing for billions of years, and things leaking in and out over that long period of time certainly skews the picture. He continues, but surprisingly, many minerals and rocks satisfy the requirement well enough to be useful for nuclear age determination. The problem is one of judicious geologic selection. And so we're looking at an unobjective, very subjective selection process that judiciously selects some and unselects others. And of course, if you're going to do this sort of unobjective selection in the process, you might as well just guess at the answer to start with. They are eliminating that which doesn't fit the presupposed assumptions. And we'll allow the evolutionary geologists to describe this process for us. But in terms of the leaking in and leaking out, notice the further documentation here from Malger, East Carolina University, in the contributions to geology. He says, in general, dates in the correct ballpark are assumed to be correct. In other words, they know what it's supposed to be. If it comes out that way, that's correct. They're published, but those in disagreement with other data are seldom published, nor are the discrepancies fully explained. They judiciously unselect. They just toss it, which is not scientific. You never throw away data when you're involved in scientific processes, but this is regularly done, typically done, in the radiometric dating processes. They don't try to explain it. They know it's going to come out wrong, and so they just toss it when it does, attributing it, of course, to things leaking in and leaking out, which is correct. That happens. But it's a selective process that's involved. Roger Lewin is describing the kind of process, and this is, again, one who devoutly believes in the process. He's an expert, editor of Research News and Science magazine, in his book Bones of Contention, describing the dating of the Richard Leakey skull, 1470. He says the calculated age was quickly refined to be 2.61 plus or minus 0.26 million years, which to anthropologists unfamiliar with the procedures of radiometric dating has a ring of comforting precision about it. Now, he acknowledges even many of the anthropologists really don't understand. They're not completely familiar with the process. They send it into the lab. It comes back with a date. Of course, when they send it in, they tell them what it's supposed to be. But here, very precise, 2.61 plus or minus 0.26 million years. Sounds good. But let's look at the rest of the story that he goes on to tell us. There were 41 separate age determinations which varied between 223 million and 0.91 million. That's from 223 to less than 1 million years. Now, that's a huge variation. 41 different times they dated it with a huge variation. After the first determination, they never again obtained that single date that they got at 2.61. Now, a huge variation, 41 separate determinations. They threw away 40 of the 41, kept the one that they wanted. They never got it again. And this is standard procedure, a description by one of the leading authorities in the field who believes in it and uses it. But he acknowledges, of course, this ring of comforting precision is an illusion. And really, we're looking at a game that's played to confirm your assumptions by throwing away 40 and keeping the 41. By the way, the book Bones of Contention is not a bad book. It, of course, assumes the billions of years, but is a pretty good history of fossil man. Instead of trying to get into the technical reasons for why these systems are flawed, I think sometimes the most practical way is to use what I call the proof of the pudding type test, to go to situations where we know what ought to be, at least relatively speaking, we know this ought to be older than that, and test it and see. Now, many of the times, of course, we can't really test, but there are some circumstances where we should be able to. For example, in this illustration with a cross-section of the Grand Canyon, we see the lowest portion there, the inner part of the gorge, the upper part, the sedimentary layers that form the upper portion of the Grand Canyon. And then those layers running over the top would be the basaltic rocks, here of the Uinkaret Plateau, would be the most recent, the very youngest. Some have suggested even the North American Indians saw this volcanic flow over the edge of the canyon and dam up some of the lower portions of the river. The river eroded down, and this would obviously be the youngest. We've got the same kind of rock, though, down in the lowest portions of the canyon, the Cardenas basalts, which is supposed to be Precambrian, many billions of years old, as opposed to historic rock. Well, here's a good test. Same kind of rock, let's test it, see how it comes out. And what we find is absolutely contradictory to the evolutionary predictions. We used a number of different methods, potassium argon, rubidium strontium, the lead-lead isochron, rubidium strontium isochron. And notice the lead-lead isochron, about 2.6 billion years for this youngest layer. But then the rubidium strontium isochron is just over 1 billion for the oldest layer. More than twice as old is this historic lava running over the top than that which is deep down in the gorge. Now, they differ with each other. I think that's significant. The dates don't tell the same time. You've got 6 different clocks in your house, and all of them tell different time. You don't really know what time it is. So they're not in harmony with each other, and they do not meet the predictions. Here's a way to test, and we test it, and we see obviously there's a serious problem here. We performed a test at Mount St. Helens, taking 5 different samples from the dome that was extruded actually in '86. Here is, at the time, this would have been an 11-year-old rock hardened there in the dome. And look at the dates we got, from just almost 500,000 up to almost 3 million years old for lava that actually formed in 1886. Now we're told that when it melts, when it forms the lava, all of the gas, potassium argon in this case, escapes so that the clock is reset. And so on that basis, they say we can use this radioactive rock to actually date. You can't date in the same way the sedimentary rock. But here the gas begins to form from the decay of the potassium, and the argon is supposed to be released entirely. Now then we see that's not so. It would obviously be the case. It doesn't reset the clock when it hardens, as is supposed. 3 million year old rock, which is actually 11 years old, is just a good example of what happens when you can really test it. Of course, most of the times you don't have an absolute means of testing, and so they assume that must be accurate. Radiocarbon dating is what we actually hear most about, though it has the least significance as far as the evolutionary procedures are concerned, because it only covers just a few thousands of years, maybe 50 or 60, depending on how precise a system being used. This was invented by Willard Libby, 1949, won the Nobel Prize for it. But just going again to the bottom line, notice the statement by Robert E. Lee, writing in the Anthropological Journal of Canada. He says, "The troubles of radiocarbon dating method are undeniably deep and serious. Despite 35 years of technological refinement, better understanding, the underlying assumptions have been strongly challenged." Now, this is not just a matter of things leaking in or leaking out, lack of a clue, but the fundamental assumptions have been challenged. For one, you have to assume the amount is the same in the atmosphere, and we've learned that's not the case. Libby says it would be constant after 30,000 years, and it isn't. I think that has some implications. It's increasing. That throws the calculations off, but the fundamental assumptions, he says, are a problem. Then he says it should be no surprise then that fully half the dates are rejected. Now, my experience is that's very conservative. I have a good friend who works in the Ball State Lab up in Indiana, a gentleman. We disagree on the age of the earth, but I was there visiting. He was gracious enough to show me through the carbon-14 lab. He was dating a peat bog, and he was trying to get the age of 25,000 years, which he knew was the age. All of the ages, though, had come out at about 5,000, which told him this must be recent contamination, and he was on the 20th effort. He says, we're going to get a good one yet, but he'd tossed the first 20. This, as Roger Lewin says, is the way the game is played. Here, Robert Lee acknowledges at least half of the dates are rejected. The wonder is surely that the remaining half come out to be accepted. There are gross discrepancies, the chronology is uneven and relative, and the accepted dates are actually selected dates. They are judiciously selected, and you judiciously unselect those that don't fit. They're not in the ballpark, and so you don't publish it, you don't try to explain it, you just say, must be contamination, throw it away. And you do that with at least half, he says. My experience is it's considerably more than that. This is not science, as you can see. This is not really the way science is supposed to proceed. The labs typically do not date unless they know what the age is supposed to be, so they know what to throw away. Now, double-blind tests provide a protection against this kind of prejudice. This is just the opposite of the double-blind test. You've got to tell them the answer to start with, and then they come up with that answer by tossing the contradictory material. Again, to the proof of the pudding type arguments with carbon-14, we dated some wood from the Glen Rose limestone, where I've been working for the past 15 years. This is wood from the layers supposed to be 110 million years old. We sent it to the UCLA carbon dating lab. It came back 890 years old. This was insulated within the rock. We found another carbonized stick, maybe 100 yards away, covered with clay, insulating it from the water, encased in the limestone, newly exposed. That came back 12,800. That's very different from the less than 1,000, and both of them radically different from the 110 million. Now, of course, you shouldn't be dating, we're told, with carbon-14, things that are supposed to be millions of years old, because all of the carbon-14 would be gone within 50 to 60,000 years. Yes, but it isn't. It's still there. And so we see the theories are being tested, and they fall short. We have excavated 2 dinosaurs from this Glen Rose limestone, and here we see a large ilium bone being excavated here by Bob Summers, supposed to be 110 million years old from the Glen Rose limestone, turned out to be 19,000 years old. Again, carbon-14 should have been all gone. It was not, which we find is typically the case with material that we date from these layers. There are untestable assumptions necessarily involved. Let's summarize. First, a constant decay rate is assumed. We know there are significant problems with that. Now, most of the experimental evidence shows a small percentage, but we really don't know what controls it. We do know it is not constant. The ratio of daughter to natural is assumed. You have to guess how much is natural and how much is radiogenic, and so that's an assumption. And then you have to assume what the beginning conditions are. How much was at the bottom to start with of the hourglass. You have to assume that there was no leaching or addition of the parent material and no leaching or addition of the daughter material. There's 4 assumptions: leaching or addition of either parent or daughter. And then number 8, you have to assume that all of these assumptions are valid for billions of years. Now, that's a pretty tenuous tower of assumptions that cannot, just on the face of it, be that which you depend on. You can understand the problem. Plus, there are areas where we can test, and where we can test, we see failures. We see, for example, the methods themselves are discordant. We can test one method against the other. They don't come up with the same dates. The uranium-lead dates are invariably older. The scientific method is not followed. You don't dump data. You don't know the answer to start with. Certainly not in the double-blind procedures. That's the opposite of the scientific method. And the proof of the pudding type test, where like with Mount St. Helens or with the Grand Canyon or with the Glen Rose limestone in Texas, you know relatively what ought to be, and you find out it isn't. You find that they fail the test. When there are ways to test, you find the failures obvious. And so I think there's good reason to have serious doubt about these methods. Interestingly, W.D. Stanfield, who's professor of biological science in California, says in his book, Science of Evolution, he's an anti-creationist. He says it's obvious the radiometric technique may not be the absolute dating methods they're claimed to be. They are not. I think he's right, though he certainly is prejudiced against the creationist. He says age estimates on a given geologic stratum by different radiometric methods are often quite different, sometimes by hundreds of millions of years. There is no absolutely reliable long-term radiological clock. And it's a little uncomfortable for me, but I find myself in complete agreement with Dr. Stanfield, even though he's a very strong anti-creationist. Why do you think the Earth's old? Well, first response, radiometric dating. Well, maybe that's not too good a reason after all. And after we talk about that, then I come back to the same approach. Now, why do you think the Earth's old? Well, the next response usually involves the geologic phenomenon. All of the layers, all of the fossils take millions of years to form. And so the Earth just looks old when you see all these layers and all of these fossils. Well, this is what I enjoy talking about. Geology is my field. And invariably we'll see that these geologic processes are rapid. You get into graduate school, they tell you about these things. But we'll demonstrate. But it kind of reminds me of the cartoon I saw the other day at the Family Circus. How big does a stone have to grow before it becomes a rock? This really illustrates what is being taught, or at least some of the impressions. I was in a high school class not long ago asking how fossils were formed, and the fellow said, well, a fish dies, sinks to the bottom, over millions of years, a rock grows around it. And evidently that's what's being taught. No, rocks don't grow. If they did, you could build your house out of rock, and over years you get an extra bedroom and you den. Rocks actually deteriorate. They don't grow. Then how does this form? Well, we need to talk about that. Sometimes people say, well, these layers just gradually build up over time, and that's talking about rocks growing, and that's just as nonsensical. In fact, in some of the older stratigraphy textbooks, many of the new ones, quoting the older ones, we see charts like this, which give us the accumulation of the sedimentation rate. The Cenozoic, 1 foot per 1,400 years for limestone, for example, or in the Paleozoic, which is the major part of the record, 1 foot per 2,700 years. Now that's pretty slow, and of course we've got thousands of feet, and so we're looking at millions of years, obviously. But nobody stood around and watched and saw for 2,700 years this foot form. How did they reach that? Well, they had to divide the assumed time into the amount of rock to get these dates. You have to begin with the assumption of time to get a chart like that. But when you look at the rocks, you see obviously this is not what happened, and geology today is acknowledging that. From Principles of Stratigraphy that I was taught from at 2 different state universities, notice the statement by Dunbar and Rogers. To some thoughtful stratigraphers, this amazing discovery, billions of years is what they're talking about, presented a dilemma. Now this is not what those who studied the rocks expected. This was a problem, for if the known stratified rocks have been accumulating throughout this vast span of time, the average rate of deposition must have been extremely slow, as we've seen from the chart. Yet there is very good evidence that individual beds accumulated rapidly. When you study the rocks, you see this just is not possible, which he goes on to tell us. We see good evidence they accumulated rapidly. For example, we look at this fossil shrimp, and this is rock. It doesn't look like rock. It looks like a fresh shrimp, and most of you ladies know exactly how long it takes a shrimp to decay. It's not going to stay in your refrigerator for years and years, hundreds, thousands, even months, and not very many days. But this became rock before it decayed. Now think a minute. How long did it take this to become a rock? Didn't this have to form within days in order to preserve this kind of detail? This is the internal evidence in the strata that says, hey, this didn't take a long period of time to form. We look at this fossil of one fish swallowing another fish. Here we see a herring eating a perch. Here, in the process of eating his supper, he's frozen in the limestone. This is about a 3-foot fish here. At the rate that Schustert had proposed, you're talking about 1,000 years to cover this up, catching him before he decayed. This is nonsense. This was like something that got caught in the concrete. And when we look in the rocks, we see this over and over again. Here's a fossil fern that hasn't even had time to wilt. How long does it take a fern to wilt? Think about that. Then how long did it take this rock to form? Not hundreds of years, not even months, days at a maximum. We know that some of these things were frozen in place. Here we see one hand holding the fresh fern, but something was holding this in place while it was frozen in this unstraight position, bent. And both of them obviously unwilted, which only takes really less than an hour in some circumstances. What we're looking at is evidence, internal evidence in the strata that belies the estimates of the thousands or millions of years. Back to Dunbar and Rogers, they say internal evidence in the strata belies these estimates. In the coal measures of Nova Scotia, for example, the stumps and trunks of many trees are preserved standing upright as they grew, clearly having been buried before they had time to fall or rot away. Here, sediment certainly accumulated to a depth of many feet within just a few years. When we look at trees embedded in the sediment, extending through dozens, even hundreds of layers, think about this for a minute. What's going to happen to the top of the tree if each of these layers take thousands of years? Here's one coal seam at the bottom extending up into and through a coal seam at the top. We're looking at one event here that buried this before it had time to fall or rot away. This was a tree that testifies to the fact that it doesn't take a long time to form coal. Of course, we know that it can be formed in the laboratory in 6 hours, described for us in Chem-Tech. We know oil can be produced, by the way, in about 20 minutes in the laboratory with heat and pressure. It does not take a long time to form these things. This is a site from France where some 50 trees were found upright, buried, extending through many strata. These are called polystrate fossils, through many strata. What would it take to do something like this? Take something like a flood, transporting, cutting off in the violent transportation process the tops and bottoms of the trees, and then depositing them, extending through many layers. But again, one catastrophic event is what's represented here. Again, back to Dunbar and Rogers in their principles of stratigraphy. Abundant fossil shells likewise indicate rapid burial. At the rate of deposition postulated by Schuster, 1,000 years more or less would have been required to bury a shell 5 inches in diameter. With very local exceptions, fossil shells show no evidence of such long exposure. 1,000 years? Sometimes the mother of pearl is still shining, which can disappear under the right conditions in one afternoon. But it's beautifully preserved in the fossil record. No, the fossil record, the layers themselves show no evidence of exposure, but rather prove that they were formed rapidly. This is an ammonite from the Dallas area, where it's just a beautifully preserved fossil that could not have been out in the bright sunshine more than a day or two, but it is that way in the fossil record. This creature many would recognize as a jellyfish. This is as close to being nothing to still be something alive as you can find. Just a gelatinous mass. How in the world would you fossilize this over millions of years? It washes up on the beach dead and is going to last for thousands of years, days. We do have fossils. Here's a fossil of a jellyfish. This got caught in the concrete, and concrete that didn't take a long time to form. It formed rapidly. Of course, limestone is basically concrete, same basic chemical formula. It's certainly by analogy the same thing, and here we see a picture, a concept of exactly how this would have to have formed to see what we see in the rocks. Another good example is seen in the fossil reptile here. Looks like a fish, or maybe something like a porpoise, a shark. No, this is a reptile, Ichthyosaurus. This one is 28 feet long, but when we look closely at the interior portion here, we see actually an embryo in the interior. This was preserved well enough that even the embryo did not decay, beautifully preserved, and many of them were obviously involved in some kind of a traumatic circumstance that caused premature birth. They do give birth to live young, and in the fossil record we see them involved in the birth process, and there are actually dozens of examples of this kind of thing frozen in the limestone. Now, some of the ladies may think it takes thousands of years to get that process over when you're in the midst of it, but it in reality doesn't. But this had to happen obviously within hours in order to preserve over a 28-foot span here, this perfectly preserved illustration. Looking at a close-up here, we see baby Ichthyosaurus being born from the upper portion here, Mama Ichthyosaurus, dramatically demonstrating the rapid formation of the sediment. We're looking here at a willow, a newly found dinosaur that's displayed at the University of North Carolina. And here is the interior, or the chest cavity. And in the center of it, we see this glob, which some had said, well, it's just a glob of mud. But with CAT scans and with x-rays, they've determined that this is actually a heart. And here is the CAT scan portion showing that. Here is the clavicle. Here we see the neck bone. And here is the left ventricle. Here is the right, the left ventricle, the right ventricle, left, right. You almost see the heart beating back and forth in this fossil heart. And then the intraventricular septum. beautifully preserved in the limestone. Now, some people looking for heart transplants, and you can see them just racing with that heart before it deteriorates to... Well, this one didn't deteriorate very long before it was beautifully preserved in the limestone. But it gets worse than that, worse in terms of the evolutionist. We're looking here at blood cells in fossilized Tyrannosaurus rex bone. Notice the description here from Science, Research News. Round, tiny, nucleated, they were threaded through the bone like red blood cells in blood vessels. But blood cells in dinosaur bone should have disappeared eons ago. I got goosebumps. It was exactly like looking at a slice of modern bone. And then they continue, but of course I couldn't believe it. The bones are, after all, 65 million years old. How could blood cells have survived that long? Well, that's the question, and of course I think the answer is they could not. That's the common sense answer. No, that's not possible. The fact that you have the blood cells there say they're not 65 million years old. In fact, some have claimed to have found the DNA, which could not possibly last more than 10,000 years, according to estimates. Even the cosmic radiation would destroy it in that period of time. We'll conclude this first session with a quote from Alan Van Joplin, who summarizes what we know today about the formation of the layers. He says it's reasonable to postulate a very rapid rate of deposition. And it's reasonable because of some of the evidence we've looked at. Plus, he says there is factual evidence from both field observation and experiment. He's done work with flumes. He's watched the deposition of these things. That laminae composed of bed material, these layers, in other words, are commonly deposited by current action within a period of seconds or minutes. This is one of the leading experts in the world from Harvard, an evolutionary sedimentologist who tells us it doesn't take a long period of time, and when you look in the layers, that's obvious. And most modern sedimentologists today, stratigraphers, will acknowledge, well, yes, the individual layers formed rapidly, though they don't normally teach it in undergraduate work. We learned in our first session that the individual beds, obviously, necessarily were formed rapidly. And even the modern stratigraphers are acknowledging this. Sometimes when I'm lecturing on college campus trying to make this point to the undergraduate students, some of the professors have interrupted. Oh, we know this, we understand this. And I say, well, why don't you teach it in the textbooks? And they say, well, we're getting to that. But how do they then account for the great ages if they see that these rocks were formed rapidly? And the answer is they put the time in between the rocks. And that's what they insist. Yes, we know the layers were formed rapidly, but the time is in between. And I say, you mean where there is no evidence? And that's overstating the case from their standpoint, because there is evidence in between the rocks, and it does not indicate great age. It indicates just the opposite, even in between the rocks, as we'll see. Notice the statement by Derek Ager, who acknowledges the points that we made in the first session. We cannot escape the conclusion that sedimentation was at times very rapid. Now, he says at times, of course, when we can test, that's what we find. Indeed, that at other times there were long breaks in the sedimentation, though it looks uniform and continuous. And so the assumption is, yes, the beds were formed rapidly, though sometimes there were breaks. There has to be if we get the billions of years. But he says that's not what it looks like. I understand that. It looks uniform and continuous. Now, I think science needs to go with what we see. And as he plainly says in this statement, it looks uniform and continuous. And when we look at the fossil record, we look, for example, here at the Grand Canyon, and it looks uniform and continuous. It's interesting that when they saw very similar pictures from Mars, red horizontal layers, immediately they said, it must have been a flood there. And we see the red horizontal layers down here on Earth, and we suggest, well, maybe laid down by water, by great amounts of water, continuously, one right after the other. Oh, no, couldn't be a flood. This gets too philosophically uncomfortable for them. But it looks like it was continuous, one after the other. But if the Earth's billions of years old, there has to be time sandwiched or shoehorned in between these layers. And that's the idea, in spite of how it looks. Well, how do you account for this in spite of the fact that it looks differently? Well, he continues in his book, and by the way, notice the title of the book here, The New Catastrophism. And that is, of course, he's not the catastrophist in terms of the Noachian flood or flood geology. That would be anathema to him. He's an atheist, anti-creationist, but he is a catastrophist, as are most stratigraphers today. He was Derek Agers, past president of the British Geological Association, or was the president when this book was written. The geologic record is constantly lying to us. Now, it looks uniform and continuous. It looks like a complete record. He says it's lying to us. It pretends to tell us the whole truth when it's only telling us a very small part of it. He says, for example, nowhere in the record, in the world, is the record even part of it complete. And it looks uniform, continuous, but no, that's not the case. It's lying. It may seem paradoxical to me. The gaps probably cover most of the Earth history, not the dirt that happened to accumulate in the moments in between. It was during the breaks that most of the events occurred. Isn't this amazing? Now, in the biological record, as we'll see when we talk, when we look at Stephen Gould's concept of punctuated equilibrium, he acknowledges we see separate kinds with regular gaps in between, and it just went so fast you didn't see it change, and most of the change took place where you couldn't see it. Well, this is just almost the same thing, isn't it? It's where you can't see it that the real work took place. It was during the breaks. In fact, he continues in this same context saying it is the gaps that really matter. It's the information that's not there where we have what really took place. Well, I think we ought to go with what we see, with what is there. And you have to imagine what happened in the gaps. But when you look at the gaps, you see a significant challenge to this assumption. They just know the time must be there, and it's not in the rocks, and so it must be in between. And so that's where they put it, and just say the rocks are lying to us. Now, sometimes creationists get accused of bending the facts to fit their view, but I think that very obviously is what is being done by the evolutionist at this point. Look, for example, at the interface that we see here within the Grand Canyon. And we're looking here at the upper portion at the Coconino Sandstone. Down below is the Hermit Shell. According to the standard interpretation, we've got 10 million years at least in between. But look at the line. Does that look like 10 million years? Now, I know it's possible to have erosion. You can't have sedimentation everywhere in the world. Someplace there's got to be erosion if you have sedimentation. But I know what erosion looks like, and it doesn't look like that. It doesn't leave the knife-edge, straight, level line that you can trace for almost 300 miles. That looks like it's uniform and continuous, one following the other immediately after the other. There is some evidence when we look there at the layers. And one of the more dramatic examples of information that would tell us that this shoehorning of material, of time in between the layers won't work is seen down here in the Grand Canyon. This is toward Horseshoe Mesa. But here we see the interface of the Red Wall and the Muav limestone. The Red Wall is Mississippian. That's on up toward the middle of the geologic column, whereas the Muav is Cambrian. That's the bottom, the lowest layer in the geologic column. In between is almost 200 million years. You go from the Cambrian to the Ordovician, Devonian, Silurian, and that's missing, and at least most of it is. There are a few places where you see some of the Devonian, but most, at least in this place and in most of the canyon, it's not there. It's the Red Wall right on top of the Muav. 200 million years, that's not there, and that's not the only place where you find that kind of thing in the canyon, but that's not the worst part of this. As we look closely at the interface, we notice right on top of the Muav, we have the Red Wall, but then you go back to the Muav. And then you go back to the Red Wall, and then you go back to the Muav, and then you go back to the Red Wall, back and forth 6 times. How do you skip 200 million years 6 times? You can't go ahead 200 million years and then come back 200 million years and then go forward 200 million years and come back to it. That's nonsense. When you study Nicholas Steno's axioms for interpreting the strata, we'll talk about him later, one of the fathers of modern stratigraphy, one of his axioms is that if layers are interbedded, then they are contemporaneous. That's just good common sense. We've known that for 300 years. These layers are interbedded, and while the evolutionist has to have them 200 million years apart, they are not. They are contemporaneous. Again, this is a continuous series of catastrophic events that fits the idea of a catastrophic deposition contemporaneously within a year-long series of catastrophes, certainly much more than the idea of being separated by 200 million years. There's further evidence in between the layers. Notice that most of the layers, and many of you have seen this for yourself, have what we call ripple marks. You see this at the bottom of stream beds. Water is running over the sandy beach or at the bottom of a stream, and it leaves these ripple marks which last for minutes, maybe hours, as the water ripples the sand underneath it. But this is frozen in the rock. How does these very ephemeral temporary features, how do they get formed into rock? Well, of course, the rock has to form quickly. But this is the interface, and you find these kinds of features at virtually any bedding plane. In fact, it's been said by the leading paleontologists, you find follow any bedding plane far enough, you'll find ripple marks. Now, that says the layer that they're in had to form rapidly, but it says more than that. It also says the next layer on top of it formed rapidly, because if you leave that exposed, it will erode. Just within tens of years, those ripple marks will disappear from erosion if they're exposed, and so the next layer has to happen quickly. And so when we see ripple marks, we see both bottom layer and top layer had to form rapidly. Notice the statement here by Robert Schrock in Schrock's rock book, as we call it, Sequence and Layered Rocks. Because they are one of the commonest and most widespread of original sedimentary features, they have been described and illustrated in countless reports. Ripple marks are preserved in conglomerates, sandstones, siltstones, enclastic limestones, dolestones. Many examples have been described from rocks of all ages. I would say all environments. I don't think they're different ages. But all kinds of rocks, all supposed ages, all types. That's the most common feature that you find in sedimentary rock. And you find, follow any bedding plane far enough, you find that. Here we're looking at some of them down at Glen Rose, where you see the dinosaurs were stepping in this sediment that was then preserved very rapidly, just like they were walking in wet concrete that hardened quickly, preserving the ripple marks and the tracks. How do you get this? Well, obviously, at the interface here, you had the first layer that they're formed quickly, the layer protecting it on top of it that's been recently removed, some of it this past year, also formed rapidly on top of it. And all of the layers have this. You find it wherever you look. When you look at the bird tracks, sometimes beautifully preserved, just very ephemeral tracks that are gorgeously preserved, and you see this in virtually all of the layers. You follow them far enough, you find each layer was formed rapidly. The one on top of it was formed rapidly. Its top has a bedding plane. You follow far enough, you will find ripple marks, bird tracks, or ephemeral markings. It says each one followed the other, one after the other, and there is no time in between. Oh, there must be time in between. Where there is no evidence, well, that's not really the case. There is evidence there. Not only is it the case that there isn't evidence for their time, there is negative evidence against their time, even in between the layers. The rocks weren't formed rapidly, neither is there time in between. We can see a demonstration of this catastrophic, rapid formation of sediment in the history of Mount St. Helens. Here is the picture of the way the beautiful mountain looked before it blew its top in 1980, and then the way it looked after May the 10th of that year, where it just blew the side out and sent debris and mud, a pyroclastic cloud out across the countryside at about 200 miles an hour, laying down mud and sediment from the melted snow mixed with the debris, and of course destroying the countryside in the process. it piled up sediment up to 600 feet thick over a 2 to 3 month period of eruptions. And these layers settled out in layers, finely laminated layers about 1/4 of an inch thick on the average, formed at 200 miles an hour, most of it one afternoon, up to 2 or 3 months maximum. Now, I was taught in school that you're looking at least a year for each one of these layers. No, it formed 200 miles an hour basically one afternoon over a short period of time. We have a demonstration that we can see this happened. Now, do we know all form? No, we know it can form that way, and the idea that it has to be slow is not so. Well, when you look at it, when you can't check, you may assume that it's slow, but nobody's ever seen it form slow. We have seen it form rapidly. This is a model. I think we should rely more heavily on what we can see, especially when we look at the evidence of the rocks, and within and in between, it all says rapid. Then why assume slow? Well, that's philosophical pressures of naturalism that shoehorn this into the thinking, that cause you to say the rocks are lying to us, instead of just taking the word of the rocks, just taking it for as it appears. It's interesting that when Spirit Lake's dam broke, the water ran down through this newly laid sediment and formed a huge canyon. Now then, with a little trickle down at the bottom, you think that little trickle cut that canyon? Well, we're told that that's the kind of situation you have with the Grand Canyon, just millions of years. But if you have a lot of water over a short period of time, you have exactly the same effect as a little bit of water over billions of years. In fact, we've seen demonstrations of this. It's a good science fair project to take a little water over a long time, compare it with a lot of water over a short time in the same medium, and you come out with exactly the same landforms, the same. We know this was formed rapidly. It's about a 40th scale Grand Canyon, the same side slumping canyons, same geomorphology that we see with the Grand Canyon. Obviously, the explanation here is a lot of water, now with a little trickle left, washed down through newly laid sediment, forming the huge canyon. That obviously is a possible explanation for the Grand Canyon. In fact, we can demonstrate with laboratory experiments that the incised meanders of the canyon did not form slowly, but required catastrophic circumstances. It does not take a long time to form such landforms. Kind of reminds me of the cartoon a friend of mine drew. This million-year-old canyon was formed by Mount St. Helens in 1980. Okay, maybe you'll buy that. I think that's reminiscent of some of the signs that we see near the Grand Canyon. Interestingly, recently in National Geographic, we have the picture of this canyon, and notice what we find in the text beside it. By National Geographic, strong proponent of evolution. You'd expect a hard rock canyon, and that's the way they describe it. It is. It is from the Mount St. Helens deposit. Hard rock canyon to be thousands, even hundreds of thousands of years old, says Peter Frenzen, mountain scientist. But this was cut in less than a decade. Now, somebody tells you it takes a long time to cut a hard rock canyon. You can just tell them, you know better, and we can demonstrate it. Well, we know it takes long. Have you ever demonstrated it taking a long time? No. We have demonstrated it taking a short time. I think the rocks are not lying to us. I think they're telling us the truth, and I think we ought to be honest enough to listen to them. But there are other indications of great age that some people point to, geologic phenomenon. For example, when we go to the commercial caves, we see these formations, here the drapery-type formations, and then the columns sometimes reach all the way to the ceiling, that are supposed to take hundreds of millions of years. In fact, I was taught in the stratigraphy textbook there at Indiana University, it takes 100,000 years to form 1 cubic inch of this speleotherm material. Now, at that rate, it's obviously going to take a long, long time. Now, that rate will vary, and I think many have revised it downward, but not nearly enough to account for the evidence. How long would it take to form this at that? Well, thousands and thousands of years. Hundreds of thousands of years. Well, how can we test this? Nobody saw it that long. Well, they can measure how slow it's going, and sometimes it's virtually stopped. It depends on the rate of flow. It also depends On the ventilation, it's a chemical process that requires ventilation for the CO2 to come out of solution. Lots of factors that determine how fast it happens, and it can happen very fast. One dramatic demonstration is in Vincennes, Indiana, and here's the George Rogers Clark Memorial on the banks of the Wabash River, a clay bank here. And on top of this bank was built this memorial out of limestone taken from the area within miles of the cave you just looked at. That was Blue Springs Cave near Bedford, Indiana. And this is the Bedford limestone quarried from very near there. And rock percolates down through the cracks in this building, just like it does in the caves. And in the basement of this building, we see the same kinds of formation. These pictures were taken, the building was 40 years old. Now, they refused to allow us in. I had to get pressure from the legislature to require them to allow me in to take these pictures. Even the National Speleological Society had been denied entrance. But there were 5 columns like this, 11 feet tall, as well as the drapery-type formations in a building less than 40 years old. Now, if it takes 40 years to form formations like this, and we've been around for billions of years, where are the really huge ones? Shouldn't all the caves virtually be filled up? No. Most of them are smaller. In fact, these are relatively large compared to what you see in the caves. Some are larger, but certainly accounted for in the thousands of years. Interesting article appeared in the Dallas Morning News here just a few years ago regarding the police building, which they're getting ready to replace. It was likewise about 40 years old. Hanging from a ceiling beam in the 40-year-old building's basement are several rows of formations not usually seen so close to ground level. Stalactites. Yep, stalactites, more than 100 of the squiggly, slippery rock formations that thousands of people pay to see in places named Carlsbad and Mammoth. They are natural cave ornaments, pure and simple. And there were hundreds of them in the basement of this 40-year-old building right here in Dallas. Don't let them tell you it takes a long time. We know that's not the case. One of the most dramatic examples is here from New Zealand in a man-made tunnel in a zinc mine. And notice the barrier there toward the center, the concrete barrier with the sign on it, and the men down in the lower right-hand corner with the lights on their helmets for scale, with just tons of these soda straws, the speleotherms coming up from the floor and down from the ceiling, all within 30 years. This was a 30-year-old man-made tunnel in New Zealand. And yet, when you go into the caves, what do they tell you? Oh, it takes hundreds of thousands of years. Well, it's not so, and we know it's not so. But you look at things that have become petrified, and things that were alive, or things that were not rock that have become rock. Well, obviously that doesn't happen overnight. Yes. How long does it take? Well, it takes hundreds of thousands of years. Nobody's checked that or watched it, but that's the assumption, and we know that's not true also. One of my favorite fossils is one that we located out in West Texas, near Iraan, Texas. Now, the boot here is not fossilized, but this is a boot that was made in West Texas, a custom-made boot. We've located the maker of the boot and identified the time. This was made in the middle 50s, or at least early to mid-50s. We identified the stitch pattern. But inside, we see bones and flesh that are fossilized. We've opened this up, and you can see the fossilized bones, and looking carefully, you can even see parts of the wound, the pus material fossilized. We've had that CAT scanned, and these are bones that have become rock. The bones down in the lower part, the toe portion, is crushed. This was, I don't know what happened to this cowboy. The CAT scan person there, the one involved in doing this, wrote on the CAT scan, "Unfortunate cowboy." And obviously something bad happened to him, but his leg is fossilized. We're now calling him the limestone cowboy. So since 1950, we see the leg of this cowboy having been fossilized. One of my favorites is this fossilized hat. This is also from near New Zealand, from Australia, from one of the mines there. This was a felt hat that is not a felt hat anymore. This is rock. It doesn't take a long time. We did an experiment out west at Yellowstone National Park, where you have the geothermal pools, actually the perfect conditions for petrifying things, high silica content, almost boiling water. And we threw a log in, tied a rope around it, threw it in one of the geothermal pools there, and came back in 3 months. Not only was the log petrified, so was the rope. Within 3 months. Sometimes oranges fall in, they become petrified. I've had professors at the University of Florida tell me about petrified bones there down near Ocala, Florida, where these glass-bottom boats go over, they're feeding the alligators, feeding them chickens. The bones pass through the alligators, fall down to the bottom. That's been going on about 10 years. They went down to clean some out. The bones had been completely replaced. They're now rock, and that happened within 10 years. So these things do not take a long time. And actually, when we see how short a time is involved, then the evidence actually begins to lean in the opposite direction. And there is evidence. Now, we've looked primarily at the things that are supposed to prove the earth's old. We've just looked at their evidence. Well, we don't have time to look at much of the evidence for the young age of the earth. In fact, we'll look at a review by William Stanfield himself. But first, let's just summarize what we've been looking at. The detailed polystrate fossils, where the trees extend up through many strata, indicate rapid sedimentation. We see the shrimp and the jellyfish and the ferns and the blood cells. We see continuous sequential layers indicated by the ripple marks and the ephemeral tracks, ephemeral markings. Mount St. Helens demonstrates the fact that these layers form rapidly. We see coal and oil and cave formations we know form rapidly. Petrification doesn't take a long time. When you look at the polystrate fossils, the continuous sequential layers, the coal, oil, cave formations, petrification, you see inevitably the geologic phenomenon take place rapidly. They don't take long periods of time. These are the reasons they say it takes a long time, and they don't work. Well, what about evidences for a young earth? Let's allow William Stanfield, again, the anti-creationist, to acknowledge, as he does in his book, some of the reasons that he says, yes, there is some evidence. Here's what he gives. For instance, water from volcanoes. There's a tremendous amount of H and O that gets together to form H2O the first time, the juvenile water from volcanoes. And we've got about 600 active volcanoes in the world today, 10,000 from the past, inactive. We take an average volcano like Paracotin that's been well studied down in Mexico. If you have 70 volcanoes producing an average amount like Paracotin of water for 4.5 billion years, supposed to be the age of the earth, then you've got enough water to fill all the oceans. From 70 volcanoes. Well, we've got 600 that are active now, 10,000 from the past, but only 70 would fill the oceans, and nobody thinks it all came from volcanoes. Something wrong here. If we have all 600 going that are active today, just ignoring the 10,000, it only takes 500 million years to fill the oceans. Now this, as he acknowledges, would indicate a young age. This is not evidence for the old age. Lava from volcanoes likewise would indicate that the Earth's not been here that long. We look at 4 volcanoes like Paracotin from Mexico. Average lava production. You take 4 volcanoes for supposed age of the Earth and you account for the entire crust of the Earth. Just 4 volcanoes will do it. We've got 600 active, 10,000 inactive, but 4 of them would account for the crust. Well, a very small portion of the crust is from volcanoes. Something bad wrong here if you're assuming the Earth is old. There's a problem. We look at the pressure from oil reservoirs here in Texas. We drill into these things and blow the rigs way up into the sky with the tremendous pressures, and we can calculate how long these pressures would be maintained. You measure the porosity of the rocks. That's one of the things you have to know when you're trying to find rocks that would hold oil. And you know how long it would hold these pressures, and you find just a few thousands of years, less than 50,000 years maximum, but it's still there, and it is powerful pressure, but would all be gone within 50,000 years according to the calculations. Something wrong here with these billions of years. We look at the uranium accumulation in the ocean. This is something that we can measure pretty accurately. And the indications here is even at present rates, you find what you have there accumulating in about 12,000 years, assuming there's been no catastrophes anywhere along the way, which of course we would assume, but it certainly doesn't come out billions of years. You measure the radiocarbon in the atmosphere, which is increasing. Libby said it would take only 30,000 years to get to equilibrium. It's not there. It's still increasing. That would indicate a young age for the Earth. Likewise, with the helium in the atmosphere, this is being produced by the decay of uranium-238. There should be 10,000 times as much as we have. Well, maybe it escaped from the atmosphere. That's been tested, and there's no way to reasonably get rid of it, certainly in the amounts that they'd need to get rid of to account for the huge amount that we have from radioactive decay. According to him, the meteoric dust in the strata likewise argues against it. We have a tremendous amount, some 14.5 billion tons per year being filtered down through the atmosphere according to Patterson's estimate. Some have said that's too much, but still, there should be a great deal of it in these accumulating sediments over millions of years, but it's very rare. In fact, as Stanfield points out, you don't find meteorites in the strata. It should be a virtual reservoir because it's collecting what has accumulated over millions of years. You find, we're told, some of these basins that have been created by the impacts, but the meteorites, some would argue for a few. He says you don't find any. I think he may be somewhat overstating the case, but you certainly don't find anywhere near the amount that ought to be there if the Earth's billions of years old. Population dynamics should tell anybody. And when you look at the population explosion of the last few years, this hadn't been going on for millions of years, even many thousands of years, or we'd be standing on each other. From the turn of the century to today, we see dramatic multiplication in just a few years. You do some calculations and you see it does not work. With the billions of years, it works perfectly within the creationist estimate. These are his evidence. These are his reasons for the young age for the Earth, and I think they're good reasons. I think there are many more. But this is enough to give you an idea of the kind of evidence for a young age of the Earth, combined with the fact that the evidence for the old age of the Earth is not really very good evidence. When we weigh the models, when we look at the evidence for the young age of the Earth, for the old age of the Earth, there's many more indicators for the young age of the Earth than there is for the old age. There we're looking at radiometric dating, the geologic phenomenon, and it doesn't work very well. It all says you just have to say the rocks are lying to us in order to make it come out old. You have to throw away a lot of the data, use unscientific methods to get it to come out old, but just take the rocks as you find them, let them speak, and take their word for it, and inevitably when they speak they say young and rapid, and I believe that's what we see when we look at the rocks. I think the evidence is very strongly in favor of the young age, thousands of years, not billions of years, for the age of the Earth. I'm convinced that the age of the Earth is an absolutely critical issue in the creation-evolution controversy. Of course, many scientists, not all, but many tell us that the Earth is billions of years old. We're told that it's something like 4.6 or 4.75, depending on which authority you talk to, billions and billions of years old. And this is absolutely essential, absolutely critical for the evolutionary position. To show you the role that this plays in the evolutionary thinking, notice the statement by Lawrence Badash, who's professor of history of science at the University of California at Santa Barbara. He says, referring to the 4.5 billion year old Earth, where it began out of a spinning turbulent cloud of gas, he says, on these figures for the age of the Earth rest all of geology and evolution. This is the foundation of the thinking of evolutionary geology. It is absolutely necessary because it's impossible obviously, to have evolutionary processes happening in a short period of time. George Wall tells us how this works in the thinking of the evolutionist. He's a Nobel laureate from Harvard. He says, however improbable we regard this event, he's talking about the origin of life. And in this discussion, he points out that this is just impossible. Those are that's his term. It is so complex and so interdependently complex that you see that this is not going to happen by itself. But he says, however improbable we regard this event or any of the steps which it involves, given enough time, will almost certainly happen at least once. He says time is, in fact, the hero of the plot. Now, this is the solution, you see, to all of the impossible problems. And no matter how improbable you show it to be, it doesn't matter, you see, you have time. He continues, given so much time, the impossible becomes probable. The probable virtually certain. One has only to wait, and time itself performs the miracles. And so this is somewhat the Holy Spirit of the evolutionist that solves the impossible problems and performs miracles. You have a problem that says you just can't get this done. That's no problem. You just wave the magic wand of time. We've all heard the story of the prince kissing the frog, and magically the frog turns into the prince. And that's, of course, a fairy tale. We know that's not realistic, except it is taught as realistic. This is exactly what we're taught in the schools today if you add one simple element. The magic wand of time makes it scientific. And now then, the frog does turn into the prince, given billions of years. Well, I don't think time has that power. Time over, actually, suppose it ran fast sometimes and slow the other. The orifice got larger. Or suppose just before you looked, it had been laying on its side with proportions just like we see it, and then they turned it up 2 seconds later, you looked at it. And only 2 seconds had transpired, and you concluded 17 minutes. Well, these are the kinds of problems that are involved in the radiometric dating systems because they're not closed systems. This material leaks in and out of the rocks over billions of years, and we do know there are some factors that cause the rate to change. Some don't know that, but experimental evidence has demonstrated that. Notice the statement by Henry Fall in his book, Ages of Rocks, Planets, and Stars. He says, 2 important assumptions are implicit in this equation. And that's the one at the bottom of the chart that allows you to reach the conclusion about years. First, that we're dealing with a closed system. Nothing leaked in, nothing leaked out, in other words. And second, that no atoms of the daughter, that's what's down at the bottom, produced, were present in the system when it formed. Now, of course, we know they were present. It's a matter of guessing how much. These assumptions furnish the most serious limitations to the accumulation clock. Now, this is not a creationist saying these are assumptions. He believes in it. He's an authority in the field. But he acknowledges these are serious limitations, assumptions, that are necessary to reach the age. You don't really date the rocks. You measure the sample activity and through a set of assumptions reach a conclusion about the age. He continues saying rigorously closed systems probably do not exist in nature. And not only is a disordering factor, and as we learned when we talked about the second law of thermodynamics, the more time involved, the more disorder is introduced into the system. This is not an organizing principle that causes things to go uphill. It's just the opposite. But this is what they rely on as their miracle worker, their Holy Spirit, if you please, the magic wand to solve all the impossible problems. When we talk about the age of the earth, I like to ask why questions. People just hear over and over again that the earth is billions of years old, and sometimes it's difficult to get people to stop and think. So I just say, why do you think the earth's billions of years old? And usually the first response that we get involves radiometric dating processes. After all, they've dated the rocks. They know from dating the rocks that they're billions of years old, and most people have no idea how such processes work. And so they just say, well, that must be, the scientists have dated it. They have somewhat maybe the impression that some of the teenagers got when they heard that we were going to talk about radiometric dating. And the idea reflected here is not quite the idea. But people not knowing how to be critical on this issue just accept it at face value. And we're not going to give a school on exactly how it works, but I think you can get at least a general concept. Radioactive material is material that emits particles from the nucleus of the atom and thus decays down to become other elements. These emitted particles are sometimes detected by Geiger counters, and you can detect then the radioactivity decaying into different elements. And it's supposed to tell time, something like this hourglass. You begin with the radioactive material at the top, and it decays down to more stable materials at the bottom. For example, with uranium lead, we see we begin with 238 particles. It decays down to lead at the bottom, which is stable at 206. Of course, we do know lead occurs naturally. Some occurs radiogenically, and you have to guess at which is which. But this is the process by which we're supposed to tell time. We can use this equation at the bottom to determine that. Now, how can you, would you run into problems with this? What would be the potential problems with this kind of a time-telling mechanism? Thinking of it as an hourglass, you look at this and you know it takes an hour to run from the top to the bottom. How much time has transpired with this hourglass? Well, you look at it and you calculate and you say, well, maybe 15 minutes, 20 minutes. And if you could precisely count the grains of sand, then you could precisely tell how much time has transpired. And counting grains of sand is certainly not the problem in this analogy with radiometric dating. We can virtually count the atoms in the process. But what could go wrong? Well, suppose just before you made your calculation of 17 minutes, someone had lifted the lid and poured a lot of extra uranium in the top to completely skew the calculation. Or suppose someone had lowered the bottom portion and had let a lot of the lead out. It had been almost full down there, and they let it out, and now then it's just a little bit left, and it should have been more like most of an hour, and now then it looks like 15, 20 minutes.